Let's read the question. Find the equations of transverse common tangents to the circles x square plus y square minus 4x minus 10y plus 28 equal to 0 and x square plus y square plus 4x minus 6y plus 4 equal to 0. So here the question they are saying is that, so this is the equation of first circle and this is the equation of the second circle. So for both of the circles we have to find out equation of tangents. Okay, these two tangents which we are going to get, they are the common tangent, and also these tangents were the transverse common tangents which we are going to get. So we should find out the equations of these particular tangents. So the figure of this particular question we will just draw once by the end of the problem very clearly. So first we'll just write the given and we'll try to solve this particular problem. So let's go forward. So I can write here given equations are, so the first equation I'm just representing with s, so I can write this as x square plus y square minus 4x minus 10y plus 28 equal to 0 is the equation. So this particular equation I'll just represent with the general equation of the circle. So that is x square plus y square plus 2gx plus 2fy plus c equal to 0. So if I have to find the center of this particular circle, so that I can write c is what, minus g comma minus f. So when I compare the given equation and the general equation, so the c value we are getting this as 2 comma 5. So I'm just writing this as center 1, that is c1. So as this is the first circle, so let's do the same for the second circle also. So the second circle I'll just take s dash. So the equation is x square plus y square plus 4x minus 6y plus 4 equal to 0 is the equation. So I'll write the general equation also, that is x square plus y square plus 2gx plus 2fy plus c equal to 0 is the general equation, whereas the center, that is c, which is minus g comma minus f, is the center. So the points, the coordinates is minus 2 comma 3 we are getting when we compare the given equation and the general equation of the circle. So let's even find out the radius here. So the radius, we are just finding out the radius for the first circle, that is g square plus f square minus c. So once we submit the g value, that is 2 square, f square is 5, whereas the c value we can say that is 28, that was there in the first equation of the circle. So I can write minus 28 under root. So 2 square in the sense that was 4, whereas the 5 square it was 25 minus 28. So 4 plus 25 it is 29. So 29 minus 28 is nothing but 1. So this is the radius for the first circle. So let's find out the radius for the second circle also. So I can write radius, which is r2, equal to g square plus f square minus c. So here if I just submit those values, that is minus 2 whole square plus 3 whole square minus 4. So this 2 square is nothing but 4, whereas the 3 square is 9 minus 4. Plus 4 minus 4 get cancelled. So we are remain with root 9, which the radius we are getting it as 3. So now we got the radius for the first circle and the radius for the second circle. Even we got the center of the first circle, even the center of the second circle. So we are just finding out now the distance between both of the centers of the circles. Alright, so I can write here the distance between two circle centers. So center 1, center 2 is. So I can write the distance formula I'm using here to find out the distance between two centers of the circle. So I can write the first center as x1 y1 and the second center is x2 y2, whereas the distance formula is what, x2 minus x1 whole square plus y2 minus y1 whole square under root, when the points were x1 y1 and x2 y2. However, the centers we got, the first center is 2 comma 5 and the second center we got it as what, minus 2 comma 3. So we are going to just submit these values here. So I can write c1 c2 equal to x2 minus x1 whole square plus y2 minus y1 whole square under root. So let's submit these values. So these are x1 y1 and these are x2 y2. So let's submit the values. So here x2 is minus 2 and x1 is only 2, so here I can write square plus y2 is 3 and y1 it is 5 whole square. There is even under root, so let's solve this further. So this is minus 2 which is minus 4 whole square plus 3 minus 5 which is minus 2 whole square, even there is under root. So this will be getting minus 4 whole square, it is 16, and minus 2 whole square, it is 4. So 16 plus 4 will be getting the value as root 20. So root 20 approximately we can write the value as 4.4. Okay, so we got the distance between the center 1 and center 2 of the circle, both of the circles. So we'll even add both of the radius of the circles, that is radius 1 plus radius 2. So the radius 1 we got it as 1, whereas the radius 2 we got it as 3. So 1 plus 3 we will be getting it as 4. So when we add both of the radius we are getting only 4, but the distance between the center of first circle and center of second circle we are getting 4.4. So which means both of these circles were not at all meeting. So I can write here, therefore C1 C2 is greater than R1 plus R2. So if we observe the figure, this is the figure for the both of the given circles. This is the first circle equation and this is the second circle equation, where even we could observe the points also, the centers. The first circle is 2, 5 and the second circle is minus 2, 3. So when it comes to see here, see the distance of center 1 and center 2 is the bigger compared to the radius of both of the circle. The radius of second circle is 3 and the radius of first circle it was only 1. But the distance from center 1 and center 2 it is 4.4, which is the center is bigger compared to the both of the sum of these radiuses. Alright, so we can easily understand here is that the both of the circles were not at all touching. There is gap between one and the other circle. So we'll write that point that both of the circles were not meeting each other. So I can write here, two circles do not touch each other. Alright, so this is as simple as that. So now we will even find out the point where both of the tangents of this second circle and first circle, the tangents were meeting at one particular point. So we'll just find out that particular point. So we'll say we'll just write that as, therefore the point of intersection of transverse common tangent. Alright, so there are two tangents, right? So their internal center will write that as, so I can write intercenter of similitude. So the internal center of similitude is divides C1 C2 in the ratio. So the ratio is what? R1 is to R2. So I can write in the ratio R1 is to R2. So it was of course internally. Alright, so we'll just write the points and we'll just submit. The center 1 that is 2, 5 and center 2 it is minus 2, 3, whereas the radius 1 and the radius 2 ratios is 1 is to 3. Whereas the point we have to find out, the formula is R1 x2 plus R2 x1 by, this is R1 plus R2 and this is R1 y2 plus R2 y1 by R1 plus R2. So let's submit these values and we'll see whatever will be getting the value here as. So I can write here R1 is 1 and R2 is minus 2 and R2 this is 3 and x1 it was 2 by R1 plus R2 which is 1 plus 3. So whereas the R1 is 1 and y2 is 3 plus R2 is 3 and y1 is 5 whole by 1 plus 3. So now let's solve this further and we'll see what do we get over here. So 1 into minus 2, which is minus 2 plus 3 2s, it was 6 by 1 plus 3 4, whereas this is 3 1s, it was 3 plus 3 5s, it was 15 by 1 plus 3, which is 4. So this I'll be getting this as minus 2 plus 6, it is 4 by 4, 3 plus 15, it is 18 by 4. So this 4 by 4, which is 1, and this is 18 by 4, which is nothing but 9 by 2. So this is the point where both of the tangents were meeting. Alright, so let's make a simple figure and we'll try to understand. So here we could clearly understand the figure. This is the first circle and this is the second circle, whereas here you can see the point here. So this is the point, this point I was just writing over here as there is no place there. So that is 1 comma 4.5 is the point. So at that particular point, these both of the, means I didn't draw both of the tangents. Once we got the equations for both of the tangents, then we will draw the figure at the end of the problem. So however, at that particular point, both of the tangents were meeting. So that point is 1 comma 9 by 2, which is nothing but 1 comma 4.5. 9 by 2 is nothing but 4.5. So that was a point where we are getting over here. So this is a simple figure to understand. So even by using this particular figure, we will just find out the common tangent. Okay, so I can write here, let m be the slope of transverse common tangent. So this particular tangent which we are going to make is the common tangent for both of the tangent equations. So I can write equation of transverse common tangent. So that is, the equation is y minus y1 equal to m into x minus x1. So let's submit these values. So this is y minus y1 is 9 by 2. So this is the point, whatever we got, we just submitting over here. So this is y minus 9 by 2 equal to m into x minus 1. So let's solve this further. So I can do LCM. This is 2y minus 9 whole by 2 equal to, so this is the m into x minus 1. So if I send this 2 to this side, this 2 to this side, so let's write over here whatever we get next. So that is 2y minus 9 equal to 2m into x minus 1. So let's submit this 2m inside and we'll see what do we get. So this is 2y minus 9 equal to 2m into x minus, this is 2m. So if you bring everything to one side, so we'll be getting this as 2mx minus 2y minus 2m plus 9 equal to 0. So this is the equation 1. We'll just take this particular equation as equation 1. So this is the common tangent equation for both of the circles. So we'll say that as 1. So we'll do this further. So I can write here 1 is tangent to the both of the circles, but at this particular time we can just take either circle 1 and circle 2 and we'll just find out the perpendicular distance, where by that we'll be getting the slope of the particular problem. So I'm just taking the first circle. So the first circle we represented with s, so I'm just writing this as s equal to 0. So in this particular figure you could clearly observe I'm just taking the first circle. We can either use the first circle or second circle, anything is fine. Here I'm just using the first circle. The radius, or we can say the perpendicular distance of this particular circle to this tangent is how much? That was the radius, we got it as 1. So we'll just use this particular one. Even the center of the first circle is what? 2, 5. So we'll use this. So I can write over here that is, whereas the d is equal to r, because the radius and the perpendicular distance the both were same, so we're just writing d equal to r. So d is not the diameter, d is a perpendicular distance, so I can write here d is perpendicular distance from center, which is 2, 5 for this particular circle. Of course, to the line, whatever we obtained as the equation 1, that is 2mx minus 2y minus m plus 9 equal to 0. Alright, so let's find out the perpendicular distance by using the formula, that is to the center to the perpendicular line for the circle. So this is the formula we'll use. So I can write this as perpendicular distance from x1 y1 to the line. Suppose if that is the general equation, that is ax plus by plus c equal to 0, then this is the equation will get ax1 plus by1 plus c whole by a square plus b square under root. So this is what we are going to get with the given equation, or with the general equation. Now we'll submit the same with the given equation, or the equation which is obtained for us after solving this equation. So we'll just take that particular equation and we'll be getting ABC values. Okay, so the general equation, I'm just comparing the straight line equation, that is ax plus by plus c equal to 0. So once we compare the a value, we are getting it as 2m, and the b value we are getting it as minus 2, whereas the c value we are getting it as minus 2m plus 9. So let's submit all these values in this particular formula. So I can write here this as ax1a, we got it as 2m, whereas the x value is nothing but 2, so I can write 2m into 2 and minus 2 into the y value, we got it as 5, so minus m is nothing but, we'll just write this as, means like we can just write this as by1, the b value we got it as minus 2, whereas the y value we got it as 5, so I just submitted, whereas the c value we got it as minus 2m plus 9. So we'll write here this as minus 2m plus 9 whole by, whereas the a value is 2m, so this is 2m whole square plus 2 whole square under root. So this is the radius of the first circle is 1. So let's solve this further. So we'll be getting this as 2m into 2, that is 4m minus 10 minus 2m plus 9 whole by, this is 2m square. So this I can write 4m square plus 4 under root equal to 1. So if I send these values to the side, I will see what do we get. So this is 4m minus 2m, in the sense we'll be getting this as 2m. So this is minus 10 plus 9, that is minus 1. So 2m minus 1 equal to, so this I am sending to the side, so this is 4m square plus 4 under root. So let's square on both of the sides and we'll see what do we get. So I can write here squaring on both sides. So I'll be getting this as 2m minus 1 whole square equal to, so this is 4m square plus 4 under root whole square. So once as I squared here, if we could just cancel here the square and the root, and we'll write the remaining. So this is 2m minus 1 whole square, that is a minus b whole square, a minus b whole square, in the sense that is a square plus b square minus 2ab. So we'll write this accordingly. So I can write this as 2m whole square, so this is plus 1 whole square, so this is minus 2 into 2m into 1. So equal to, so I'm just writing these elements again after removing the root, that is 4m square plus 4. So this I'll be getting 4m square plus 1 minus 2 2's, it was 4. So this is 4m. So this side elements I'm writing as it is. So now I'll bring this side elements to this side. So I'll be getting 4m square plus 1 minus 4m minus 4m square minus 4 equal to 0. So now I'll be getting this as plus 4m square minus 4m square get cancelled, so we are remained with minus 4m plus 1 minus 4 equal to 0. So finally the equations which I got, the m values which we got is 4m minus 3, where m equal to minus 3 by 4, or also we'll be getting this as m equal to 1 by 0. Nothing but we can say this is undefined, of course. So now we can write this as the first m value we got m equal to minus 3 by 4, and the second m we got 1 by 0. So we can assume the first m and the second m as case 1 and case 2, and we'll just submit the first equation which we got. So I can write the first equation as if m equal to minus 3 by 4, then the equation 1 is, so what was the equation 1? That is 2m x minus 2y minus 2m plus 9 equal to 0. So this we have already solved above. You can go up and you can check, then you will get it. So I can write this as 2 into the m value is minus 3 by 4 into x minus 2 into y minus 2 into, and the m value is minus 3 by 4 plus 9 equal to 0. So this we can cancel 2 1s and 2 2s, and here also 2 1s and 2 2s. So we'll write the remaining elements. That is minus 3 by 2x minus 2y. This is minus into minus plus 3 by 2 plus 9 equal to 0. So once we do LCM here, I will see what do we get. Minus 3x minus 2 into 2y plus 3 plus 9 into 2 whole by 2 equal to 0. So this is minus 3x minus 4y plus 3 plus 18 equal to 0. So here I can solve this further. I can write minus 3x minus 4y plus 18 plus 3, which is plus 21 equal to 0. So if I just take minus 1 common, I'll be getting this as 3x plus 4y minus 21 equal to 0. So the equation is 3x plus 4y minus 21 equal to 0 is the equation obtained, right? So this is for case 1. We'll even find out for case 2 also. So I can write case 2. Okay, so in case 2 the m value is 1 by 0, which is undefined. Then the equation is, so equation 1 is what we have solved with the equation 1, where the equation 1 is y. So you might have remember the equation where before submitting the p value, so this is the equation which we have taken, that is y minus y1 equal to m into x minus x1. You can go back and check. Once we got the p value, the point where the two of the tangents were meeting, this is the equation which we have taken and submitted the p value. So I'm just submitting here the m value, so I'll be getting this as y minus 9 by 2. This is the point, right? So equal to m value is nothing but 1 by 0, and this is x minus 1. So as this is the point, which is 1 is x and y is 9 by 2, I just submitted the values. So let's solve this further. So if I send this 0 to the side, so I can get y minus 9 by 2 into 0 equal to 1 into x minus 1, where this all part will become 0. So we are remain with x minus 1 equal to 0. So this is the equation for the second tangent of the circle. So we can write finally the conclusion. So you could observe this is the first tangent equation and this is the second tangent equation. So therefore we can write conclusion, that is equations of transverse common tangent are, so the first equation we got 3x plus 4y minus 21 equal to 0, and the second equation we got x minus 1 equal to 0. So we'll make the figure and we'll just summarize whatever we did. So here is the figure which we got. That is, this is the first circle and this is the second circle, and here is the point where both of the circles were meeting, where the point we got it as P, which is 1, 4.5, and the center of the first circle is 2, 5, and the center of the second circle is minus 2, 3. Whereas the first tangent equation we can write, that is 3x plus 4y minus 21 equal to 0, and the other tangent equation is x minus 1 equal to 0. So these are the both of the tangents which were touching the circles transversely, and they are meeting at this particular point P. So this is all they asked us to find out, the equation of the both of the tangents. Alright, So we got the equations for both of the tangents of this particular transverse, tangents of this particular circles. So this is all about this particular question.